death. That's pretty interesting. We'll talk more about how guys at my age range, if you're 60 plus, how can you add some muscle mass? We'll get to that a little bit later on. Well, let's talk about your research first. What did you set out to learn? And then we'll talk about how you did it.
Sure. So our research was piggybacking a lot of the great work that's been done looking at how we can reduce our sedentary time or periods in which we're inactive longer than a couple hours. And a lot of this work had been done in the area of how well we can clear the glucose or sugar from our bloodstream after we eat a meal. And it was shown in a variety of populations, healthy, young, old, individuals with metabolic syndrome or type 2 diabetes, that breaking up prolonged periods of sedentary time every half hour with brief 2-minute walks is able to clear the sugar from the blood more efficiently and allows insulin to do its job, which is certainly important for reducing the risk of complications associated with metabolic disease. But we also know that the way that when we eat a meal, the amino acid building blocks in the protein that we eat are used to build muscle. And it's an opportunity for us to rebuild muscle when we eat. And so we wanted to understand, well, do we see a similar phenomenon as blood glucose or the sugar as we do with these amino acids? And so we replicated previous studies that looked at every 30 minutes breaking up the sedentary time with 2 minutes of walking. But we also wanted to understand, well, what if someone doesn't have the ability or the environment to go for a short 2-minute walk? We reasoned that, well, if you can sit down, you can also stand up in your environment. And so we wanted to look at the novel aspect of incorporating body weight squats. And when I say squats, it's really just we had individuals rise up from their chair onto their toes and sit back down. And doing this 15 times was the same energy cost as going for a moderate 2-minute walk. And we wanted to see what happened to the muscle or how it responded to the food that we were giving people over a simulated workday of 7.5 hours of otherwise seated time. What we were able to do, though, is that in the protein that the people were eating, we added what is known as a stable isotope. And this is an amino acid building block that is a little bit heavier than those that are normally found in the food that we eat. And so we're able to track where it goes in the body. And through taking small samples of muscle, we're able to determine whether or not the amino acid that they ate at their mouth ended up in their muscle. And if it did, we know that it was used to help rebuild muscle, which otherwise would be fairly low if we're not being active. And we saw that both the walking snacks and the body weight squat snacks were equally effective at improving the utilization of these amino acids for muscle protein synthesis. And we believe that this is an important metric to look at when you're trying to find ways to optimize muscle mass and quality, because in otherwise healthy individuals, so not clinical populations where there's accelerated muscle loss, how well people are able to build muscle in response to the food that we eat is one of the best metrics of whether or not they're going to be able to hang on to the muscle or gradually start to lose it.
Got it. So that's pretty interesting. You're able to track and find out whether those exercises, just those little snacks, really did build muscle. And I think the result was pretty clear, right? I mean, it's obvious that it does indeed.
Yeah, and we were quite surprised at the effect size, and so it's what was a moderate to large effect size, which clinically is quite relevant. This is still a proof of principle study. We're looking at how well they're able to build muscle over 7.5 hours, a simulated workday. We still need the longer term trials to see if this pans out into a maintenance of muscle mass or muscle quality over longer periods, as I mentioned, maybe 3 months to rebuild the whole muscle. But we certainly believe that this proof of principle study bodes well for larger clinical trials that are aimed at more functional outcomes, such as the quantity and quality of muscle mass.
Okay, so help me understand how we bring that data out of the lab and into my life. What is this really telling me, and who is it most helpful for?
Well, I think it's most helpful for people who are not able to for maybe attend a gym or be active throughout the day, or who are confined to situations in which they're seated for long periods of time. And an example might be with the holiday season coming. If you're going to be traveling on a plane or a long haul flight, you know quite well that that's quite a bit of sedentary time. And so really we think that just breaking up those sedentary periods with any type of activity, whether it be going for a walk, doing some sit to squats. I've heard people who are interested in doing some jumping jacks or push-ups. I mean, those are a bit more aggressive, but certainly any muscle that you're able to use is going to obtain this benefit of being able to use the food that we eat more efficiently.
So, and you set it up so that I have a little timer and an alarm. I'm getting up every so often, right? That's easier to do now than ever with our smartphones, having a timer right there. And you know, is it as simple as just as we're seeing here on the screen, just getting up, stretching, any kind of activity at all, or does it have to be something strenuous?
Yeah, so I don't think it needs to be strenuous at all. Our walking was a very moderate pace. I think what we need to focus on though is ensuring that we're using the muscle and we're contracting it. And so while stretching might be good for posture or relaxation, this is an example here on the screen of the push-ups that they're being active with that muscle. And it's that the contraction of the muscle we think that is important. It helps move the blood through the tissue. And if that blood is carrying the amino acids that we just ate, then they're going to be able to be used by the muscle. So it's really just finding ways that we can use it. And the old adage, if you don't use it, you lose it. This isn't a prime example of that, I think.
What is there about I know that you chose a squat because it's something you can do anywhere, right? Stand up, sit down, that's essentially a squat. But is there something about this exercise that's particularly helpful?
Well, it's a very functional exercise, and so individuals who may be aging or having a harder time navigating their environment, certainly you want to be able to be able to stand up from a seated position, and that's one of the functional tests that we use to determine someone's frailty score. And so, having difficulty getting up from a chair and walking is one way that we can score how functional older adults are. Or individuals in general. But the other point I think is that we carry most of our muscle mass, about 60%, in our legs. And so if we're able to use our legs, then we're using more of the muscle in our body. And that's certainly going to be important for clearing the sugar from our blood, but also maintaining most of the muscle that we carry from a day-to-day basis.
Yeah. So as I like to think of my program, my audience as being, probably in the 45 plus range. And so as you get to my age, which is substantially beyond that, it's tough to add muscle. So what's happening there? Why does that make it so hard? And why is it so important?
Well, I mean, that's a great question, and that's a big one to unpack. There are age-related changes in the muscle that make it more difficult for us to gain muscle as we age, and it could also be related to changes in the hormones circulated in our bloodstream. But certainly, at any age, we're able to gain muscle. And I think that's an important point, is it doesn't matter whether you are young or old or active or inactive, we all have the capacity to build muscle. And it's really just providing a stimulus or to the muscle that's greater than what it normally encounters throughout the day. And that's going to be the signal for muscle to grow. So, we do find it harder as we age, but we can still gain that muscle. And I think it's important for people just to stay active. And certainly there's a lot of research looking at even just walking is effective. Certainly you can't build muscle just by walking, but you can hang on to the muscle that you do have. And 8,000 steps per day is a fairly good target for older adults, and we see that as being around the threshold at which disease risk reduction is maximized and all-cause mortality is minimized. So it's simply just finding ways to walk, and I think our study also shows that maybe how you spread it throughout the day is important, and maybe it's not as much as every half hour, maybe we can see the same benefit every hour, but certainly accumulating those steps and trying to minimize the time at which we're seated for prolonged periods is going to be a good low bar to finding ways to hang on to the muscle that we do have.
Yeah, so I guess just getting off the couch and walking to the fridge is some level of exercise, as long as I don't open the fridge and go crazy there, right?
It depends what you're selecting from the fridge, of course.
Yeah, exactly, of course. So you focused a lot on muscle, but the same story happens when you're trying to clear blood glucose, right? Just a little bit of activity can make a big difference.
Correct. Yeah, and we see this, and not just in our research. These were otherwise healthy young adults, not sedentary, not particularly active, but we were seeing the benefits there in the far as that they didn't need as much insulin to clear the same amount of glucose from their bloodstream. But certainly the effects that we see through this reduced sedentary time are more pronounced in people who have reduced insulin sensitivity. And so it really is a great way to reduce our risk for all-cause mortality and metabolic syndrome, and really look at how we evolved as a species. And we never had this environment where we had food readily available and the reason to be active so low. So a lot of researchers starting to look at, well, this is really, being active is the default position, and being inactive is now leading towards that disease state because it's something that we never did as a species as we evolved.
You are echoing what a cardiologist recently told me. His claim is that our bodies are just confused. Never in our evolutionary history have we had so much food around us, such high dense calorie foods, and have we ever moved so little? So yeah, that makes a lot of sense. As you get older, does it matter what muscle I ought to be concentrating on, upper body, lower body?
In general, I'd say no. I think you want to make sure that you have whole body muscle mass and it's all functional. But certainly, the legs are important, as we spoke about. That's where we carry most of the muscle in our body, and it's going to be a good metabolic engine and a spot where we can put the glucose from our food. We can clear it more efficiently. So making sure we have leg muscle mass is important for navigating our environment, getting up off the chair, moving upstairs, and playing with the grandkids, as an example. But we also see that grip strength is tightly regulated with all-cause mortality as you age, and so opening a jar, for example, that is quite dependent on grip strength, being able to carry groceries as well. So I don't think we need to compartmentalize on what's most important, but those are the areas where I think being able to have a strong grip and strong legs are probably a good starting point. And I'm not a biomechanist, but certainly being able to keep yourself upright through a strong core is going to be very important as well.
Yeah, that core strength is a significant factor in your safety and your ability to move and remain pain-free as we age. That's absolutely correct. So what's next for your research? Where are you going?
Well, we're actually following this study up in older adults, and for the reasons I just spoke about, we need to make sure that we're finding ways for older adults to hang on to, or preferably even gain muscle mass as they age. But we think that this sedentary periods are going to be more detrimental to the muscle mass and health as we age, because there is an age-related reduction in muscle mass and function. And so we're following this up to see if the activity squats are as effective. And really, we're trying to simulate an environment where older adults are confined to lower daily step counts, whether that be because they become ill or weather-related restrictions have kept them inside. Certainly, we see that being less active as we age leads to loss of muscle, as we are when we're young, but it actually is harder to gain that muscle mass back as we age. And so we really want to find ways that we can minimize that And so we're following it up to see if this reduced step count is a paradigm in which we can maintain the muscle quality in older adults, which we think is very important to study.
Does it matter what type of protein I'm eating as I get older? I know your digestive system shifts. You don't produce as much acid to break down some foods. Are there some that are better for muscle mass when I'm getting an advanced age?
Yeah, so I think first and foremost, I think finding ways to make sure total protein is adequate. And, we're seeing the current recommended dietary allowance, which is the low bar designed to minimize disease risk reduction, is about zero point 0.8 grams per kilogram of protein per day. We're seeing that actually might be increased as we age, and a lot of consensus statements focused on aging health are recommending about 1.2 grams per kilogram per day. So about 60% more than the current RDA. And I think that is the first bar to try and reach. If you're talking about protein quality, it seems that proteins that are higher in or more enriched in the essential amino acid, meaning a building block that our body can't make and must obtain from the diet, the amino acid leucine, seem to be fairly effective at turning on this process of protein synthesis, especially as we age. So typically that leans towards animal-based dairy-type proteins are particularly enriched. But certainly if that's not an option or a decision that people are willing to make, then certainly meeting that low bar of 1.2 grams of protein per kilogram body mass will be a really good starting point.
So try to get it from natural foods and not necessarily a protein supplement or protein shake or something like that.
Yeah, I think the supplements can be something that's convenient, or if someone's not able to get enough in their diet. But certainly, I would strongly advocate for whole foods. There's a lot of other nutrients that come with whole natural foods, and we're also seeing in the research that we do, looking at how well our muscles able to rebuild after a meal, that there's some unidentified currently factors that seem to allow whole foods to outperform isolated protein sources or engineered protein sources. So we've recently completed a study in young adults showing that if they ate salmon, they actually were able to build a little bit more muscle than if they ate the same quantity of protein and types of fat. So we re-engineered the parts of salmon, and it just didn't seem to be as effective. So certainly, coming back to the evolutionary piece, we evolved to eat food, and the supplements may be effective and more effective in some populations, clinical populations, but certainly I would not advocate that they be a meal replacement.
Well, maybe I think it was Marvin Gaye, ain't nothing like the real thing. It sounds like he had it right.
Yes, more ways than one.
I appreciate your time today. Thanks for sharing what you know with us, Daniel.
Thanks for having me, Lee. Take care.